in part B, let's find f minus g of x. Ooh, this is a little different, you guys. What is the input here? It's not a specific number, right? It's a symbol that represents a domain value. So f minus g of x, all right, what do you suppose the definition is if you want to break it up? If you want to break it up, then by definition, what do you suppose that's equal to? F minus g of x equals f of x minus g of x. You subtract g of x from f of x. I can't talk. And again, it looks like the distributive law over subtraction, right? Is it that? No way. No way. All right, so there's no specific input to put in, so this is a little bit different than the last problem. I'm just going to write the formula down for f of x. I'm just going to write the formula down for g of x, and I'm going to combine like terms. Well, there's another little step in there, but it's basically going to be combining the formulas using algebra you already know about. So f of x was what? 2x plus 8. So I'm going to write that down. F of x is 2x plus 8. So I can replace f of x with the entire quantity 2x plus 8. Minus, parentheses, g of x. G of x is negative x squared plus 3x plus 5. Negative x squared plus 3x plus 5. What do you notice that I put around g of x? So I'm replacing g of x with its formula, right? What did I put around it? Parentheses, because you have to subtract the entire formula. Okay, I could have put parentheses around the front, right? But around the 2x plus 8, does it do any good? Didn't really need to, so that's why I didn't do it. But if ever in doubt, put a set of parentheses and then go from there. So yes, you can drop the parentheses in front, but in order to get rid of the parentheses around the negative x squared plus 3x plus 5, what do you have to do? We call that, now this really is the distributive law, isn't it? We're distributing, it's really a negative 1 we're distributing, but we think of it as distributing the minus, right? So what do you get if you do that? The opposite of negative x squared plus x squared, right? You got to include the operation. Distribute a negative over a plus 3x, you get minus 3x, and then minus 5. And then, now this is old stuff to you guys. You learned this in beginning algebra. Combine like terms. We usually we go in descending powers of x usually. So I'll put x squared in front because I don't see a like term with that. But what about the x terms? If you combine those together, 2x minus 3x makes minus x, right? So make sure you put in the operation. So we took care of that guy, we took care of that guy, took care of that guy. Oh, 8 minus 5? Minus or plus? Plus 3. Plus 3. Okay, so this is a formula now for f minus g of x. So if you had a specific input, if you wanted to find f minus g of, say, what was the input in the last one? Was it 2? Let's say you wanted to find f minus g of 2. Then you could do it one of two ways. You could use the definition and say, oh, f minus g of 2 is f of 2 minus g of 2. And we already know what those are. What did those turn out to be from the last example? Those turned out to be 12 and 7, right? So we could take 12 minus 7 and be done. Because we already knew it's quicker because we already knew what it was, right? 12 minus 7 is 5. Or what I'm saying with this example is you could take this generic formula and plug in 2, and you better still get 5. Let's see if we do. Then if we don't, we did something wrong on one of the last two examples. So let's now find f minus g of 2 using this formula. So what does this formula tell me to do? Replace x squared with 2 squared, or 4. minus 2 plus 3. Is that going to equal 5, I hope? Yeah, because you get 4 squared minus 2 is 2 plus 3 is 5. So notice that it matches up. So which way is easier? It depends. If you have to put in a lot of inputs, aren't you going to want the formula? So you don't have to go f of x minus f of whatever the input is minus g of whatever the input is every time. Yeah, that's where the formula comes in. So if you have to find f of 2, f of 5, f of negative 8, f of 1,000, you want the formula. You don't want to have to take f of whatever the input is minus g of whatever the input is every time. Okay. So look at what we've done. We've analyzed how to add two functions together, right? And subtract them. They're very similar, right? The definition, f plus g of x is f of x plus g of x. F minus g of x is f of x minus g of x. So just based on that pattern, how do you think we're going to break up f times g of 2? So this is multiplication. How do you think we're going to break up f times g of 2? By definition, we're going to say that's equal to good. We're going to add the corresponding outputs of f of 2 and g of 2, or not add, but we're going to multiply the corresponding outputs of f of 2 and g of 2 together. Oh, but we already know what those are. I think f of 2 was 12 and g of 2 was 7, is that right? Yeah. Or do I have them backwards? Does it matter if I have them backwards? Not for multiplication, but I have it right. And what's 12 times 7? 84 it must be. Now, could I find a formula for f times g of x? I could. I could do it. I'm not going to do it right now. We're going to talk about multiplying later on, but I could come up with a general formula for that as well. Part D, f divided by g of 1. Based on how f and g split up for the other operations, how do you think it splits up here? By definition, what do you think f divided by g with an input of 1, how do you think that breaks up? F of 1 over g of 1. So see if you can find f of 1 divided by g of 1. What do you have to do first? You have to evaluate f of 1 and then g of 1, right? And then create that ratio. Tell me what you get. So if you're not following, just find f of 1 first. So plug in 1 in for x in the formula for f. And then find g of 1. That's a good jumping off point. Anybody have f of 1? 10. Anybody have g of 1? G of 1 is 7. I believe you. So what's f of 1 divided by g of 1? 10 sevenths. Does that make sense? What if g of 1, this is a what if question, you guys. What if g of 1 had turned out to be 0? Would that be a problem? Yeah, then you'd have 10 over 0 if that were the case. You can't divide by 0, right? So you would just say undefined. What that would mean is the input of 1, if g of 1 equals 0, it doesn't, but if it did, it would mean the input of 1 is not in the domain of this new function you've created by taking f divided by g.